All the models I review are kind of special in their own way, but every once in a while, I get to work on something that really makes me go, whoa. Whoa. This is a monster. I mean, I really hope it fits in my car kind of monster. There's actually a good chance it won't, but we'll see. As you can see, this is a Seagull Models 102-inch Savage Shock Cub from Legend Hobby. It's an almost 1/3 scale model of a European light sport bush plane capable of very short takeoffs and landings. And the model looks to have all sorts of scale features to play with too. So let's get started, shall we? The first thing I noticed was the very lovely wing bags, including the kit. It's a nice touch to keep the large wings protected from my clumsiness. The recessed hinge ailerons come pre-installed and glued into position from the factory. The same for the flaps, which are offset hinged for additional lift. I noticed the internal wing structure was well designed and built very lightweight. The heat treat covering was wrinkle-free and nicely finished. A recessed hole marks the wing mounting bolt location. The tail surfaces use C8 hinges and are completely built up to save weight. The large fuselage sports an attractive two-tone livery decals, with a large door on the right side for access to the interior. The door has a handle on the outside, and two magnets on the inside to secure it in place. Inside is a black painted cockpit that sports a dashboard decal reflecting both simple and high-tech looking instruments. From above, you can see the servo cutouts for the tail and engine controls. Looking back in through the tail, you can see an impressive open structure latticework. On the left side are cutouts in the wood for switches and charging jacks. The firewall comes completely fuel-proofed. I noted that there was some right thrust built in it as well. Cowl has a nicely finished glossy gel coat with a durable fiberglass layup. The real gem in the kit is the tail wheel assembly, a beautifully machined part with ball bearing pivot point and functional metal leaf springs. Yes, this will do quite nicely. A prominent feature are the wing leading edge slats. They're made of fiberglass and feel hollow inside. I thought they were quite nicely made and finished. There are quite a few metal wing struts and associated parts for the model. Looking at the landing gear, the A-arms are welded metal painted gloss black. Not sure what metal they used, but they certainly felt heavy duty and robust. The struts are spring-loaded and felt equally solid. 5.5-inch diameter rubber tires are air-inflated and include a filler valve. Lots of hardware bits are spread throughout several small bags. I really like the 20-ounce fuel tank. It comes mostly pre-assembled and features metal fittings and a screw-off cap. Next is the roughly 2.5-inch spinner with metal backplate and adjustable motor mount box for electric motors. Speaking of electric, there is an optional battery tray for easy battery pack removal. The two seats are mostly made from vacuum formed plastic with a wood base. The manual is not very verbose, but it does have lots of photos, with guidance for both fuel and electric power setups. Large decal sheet is of the peel and stick kind. Prints were clear and pre-cut. Lots of library you can go crazy with. They even throw in a hat. Okay, now I'm really ready to start. And we start with the wing slat mounts, which needs some of the paint removed from the fiberglass brackets before gluing into the wing. There are holes cut out of the leading edge for the brackets to slide into. Check carefully before gluing in, as I did find one of the brackets did not fit in alignment with the others, which I double-checked by placing the leading edge on a flat surface. You can see here that it sticks out a little more than the others. To fix this, I needed to file the bracket to better conform with the leading edge. Much better. After a quick test fit to double-check alignment, I could now glue the brackets into place. The first step is to square up the pieces. Mark the location with tape. Carefully cut away the covering to expose the wood. This will ensure a good glue bond. It would be pretty embarrassing to have the slats rip off in flight. Two-part epoxy is used for glue. Before the glue fully cures, double-check the squareness in 2 axes. This attention to detail paid off as the slats align up quite nicely. Self-locking nuts are used to keep the screws in place, but still allow free movement. You will need to remove the paint from the control horn stub as well. A little file did it in only a few seconds. Again, use a liberal amount of 2-part epoxy. I use tape to control the spread of the glue. You should remove it while the glue is tacky. For all the servos, I use Spectrum A6380s. These ball-bearing metal gear servos are high voltage and rated up to 160 ounce-inches of torque. I chose high voltage servos so I can run everything, including the engine, off of 2-cell lithium polymer batteries without needing a voltage regulator. A drop of thin CA reinforces the screw holes for mounting the servos into the wing mounts. Poke through the covering to expose the mounting holes. Then use the pull string to route the servo leads through the wing. Since I expect to remove the servos to fine-tune the controls, I just use a couple of screws to temporarily hold the plate in place while I hooked up the control rods. The flap servo will need to be moved to its up position before installation. You will need a double-sided servo arm with a length of about 1 inch on each side. One side hooks up to the flap, while the other side connects to the slats. Both operate together. It will be interesting to see how this will work in flight. With one wing done, it's on to the fuselage, where we'll install the remaining servos into the floorboard. Wheels are a multi-part assembly, starting with the shafts, which use brass sleeves separated by a collar. Fit the shaft into one hub half, then assemble the remaining parts around the tire. The screws were just barely long enough, so you will have to push hard. The last piece is a little hubcap that will need to be glued on. If you wish, you can further inflate the tires, but I found the pressure fine from the factory. Undercarriage brackets mount to the bottom of the fuselage. Be sure to thread lock the screws. Once the 4 brackets are in place, the crossmember mount is secured with bolts and lock nuts. The A-arms are installed next, but I had an issue where the hole didn't quite line up on one side. It turns out the A-arm weld joint was interfering slightly at the corner, so I ground off a little off the bracket. That did the trick quite nicely. Movement is smooth and easy. Now to install the side mounts for the shock struts. I had another slight alignment issue on one side, but a light tap with a hammer convinced it to go in. The whole assembly felt pretty good. I'll add the tires later. Now it's time for the engine. And oh, what a beauty it is. The RCGF Stinger 40cc twin cylinder. A newly designed gasoline engine featuring 4 bolt prop hub, electronic ignition, radio mount, slanted spark plug mounts, and Walbro carburetor. Also in the box are mounting hardware and spark plugs, high voltage compatible ignition, and of course the mufflers. Test fitting the cowl shows it fits perfectly. Oh yeah, this is going to look great. The firewall has a center mark crosshair for alignment due to the thrust offset. I measured the mount hole spacing before realizing that the manual has the mounting templates inside of it, though they are not quite to scale. I started by drawing a series of alignment marks with a ruler triangle and thin Sharpie. After double checking the hole alignment, I made some pilot holes before drilling the correct size holes for the blind nuts. I used one of the standoffs that came with the motor to pull the blind nuts tight. It's also a good idea to epoxy the blind nuts in place as well. The standoffs that came with the engine were too short, so I used the ones included with the model. Dumb me mounted the mufflers on backwards. So with them off, I took the opportunity to change the throttle lever to the optional longer one, as I thought the angle to the servo would be better. Now I could proceed with drilling out the cowl for the muffler pipes. To do this, make a couple of strips with thick paper. Then tape it onto the fuselage and over the exhaust. Once in place, emboss it by pressing down on the paper with your fingers. Cut out the holes using the lines as a guide, and recheck the alignment. With the muffler now off, install the cowl and... oh, wait. Hold the press. Alright, so as I was getting the cowl lined up and kind of getting ready just to mark the holes for the mufflers, I just couldn't help notice that the front of the cowl and basically the back plate of the propeller mount was a good, I don't know, 10 millimeters away from each other. And now that doesn't hurt anything, but it's just going to bug me that the back plate of the spinner was going to be offset from the front of the cowl, and at certain angles it wouldn't look just right. So I'm going to have to bite the bullet and actually go in and shorten these engine extensions. They look like they're made out of aluminum, so they shouldn't be too hard to hack through, cut through, whatever I'm going to do with them to shorten them up a little bit. It's kind of a pain because they're real nice. They came with the kit, and I was thinking, oh right, they look like they'd be the perfect size, not to do anything, but that's just not going to work. So I'm going to have to take the engine off, which I was probably going to do anyway for other reasons, but take the engine off. I'm going to trim these down a little bit and bolt everything back up, but then I can go on and drill the holes for the muffler extensions, which I will put on eventually. Well, off she goes. I marked about 10 millimeters off one end of the standoffs. Then use my bandsaw to slice it off. Watch your fingers, kids. The end is a little rough, so I carefully sanded it flat. Ooh, hot. And did a quick deburring around the corners. But of course, now the screws are too long. So I needed to purchase some new shorter screws, which work just fine. Now, the cowl matches up to the prop hub much more to my liking. Okay, as I was saying before my OCD got in the way, fit the cowl and tape into place. Then mark off the pipe openings with a Sharpie. I next marked a center point and drew a slightly larger circle to allow for fine-tuning of the cowl positioning. Drill a pilot hole. Then use a step drill to enlarge the hole. Take your time and you will get good results. A touch of sandpaper cleans up the hole quite nicely. And with that, just slough the cowl into... oh, what now? The pipes are too long. So I use my Dremel to... dang it! My Dremel to slice off about 1/4 inch of length. And then sand the edges smooth. There we go, that's the ticket. Perfect. Now I can drill and screw the cowl into place with pride. With the great engine battle won in my favor, we move on to the tail, where the elevator horns are attached. And while they cure, I get the horizontal stab ready for gluing. I'll need to align the stab, so on go the wings. Then I used a yardstick to check for straightness. A jeweler's screwdriver is used to make a faint line on the covering at the fuselage joint. Use a sharp knife to lightly cut away the covering. And epoxy into place. The fit was a little snug, but it will make a good bond. Some rubbing alcohol helps clean up the excess glue. Now you can install the control surfaces and glue into place with thin CA. 2 metal pieces are installed to the tail before mounting that wonderful tail wheel with 2 screws. The assembly is spring-loaded, so you will need to install the springs. Oh, gotta remember to tighten that axle bolt. Going back to the main gear, I needed to drill out the shaft hole to clean out some residual paint and metal bits. A set screw holds the shaft in place. Since the engine uses a 4-bolt pattern for the propeller, I needed to use a drilling rig, which just bolts onto the prop. You really should use a drill press, but this is a damaged prop I have no intention to fly. Plus, I like to live on the wild side. A large drill bit is used to deburr the holes. Look, Ma, it fits. With that done, time to hook up the throttle cable. I really just eyeballed the location before marking the drill hole. It doesn't have to be precise as long as it's relatively straight to the servo. And yes, I got really good at taking the engine on and off through all of this. The kit includes a plastic tube to prevent the control rod from bending, which is glued into place. My calibrated eyeball ended up working pretty good. However, my first choice at servo horn ended up being too small for the long throttle arm. A quick change to a longer arm gave me the full throw I needed. Bouncing back to the tail, I installed the elevator rods and clevises. Before setting up the rod links, lock the surfaces neutral with some tape. And of course, make sure the servo is neutral. The rudder uses pull-pull cables, which will need to be assembled before use. The coated wire is first threaded through the crimper and coupler eyelet, and then looped around a second time through the crimper. Pull tight, then gently squeeze the crimper with heavy-duty pliers or crimp tool. Now the excess length can be cut off. Piece of cake. The cable is too soft to push through the slot easily, so I taped a thin metal rod to the end as a pull guide. Repeat the crimping process just like before, but be sure to allow enough space to thread the couplers tight. Oh, and don't forget to jam nuts like I almost did. The tail has structurally supported guide wires, which use brackets held on with screws through the tail surfaces. Again, you'll have to use the same crimper technique as before to make the rigging. The door uses small metal hinges which screw into the top of the frame. Recessed slots will need to be cut out of the fuselage covering. The magnets felt plenty strong to keep the door closed in flight. At this point, I decided to hook up the ignition system. First installing the spark plugs, and then the dual output electronic ignition module, which has a pretty wide voltage range. Some Velcro at the bottom of the firewall makes a good spot for mounting the module. It'll take a firm press to snap the spark plug caps on. So much so that I accidentally broke one of the plugs. Fortunately, I could pull out the broken piece with some hemostats. Now, more brackets are added to the wing for the struts. The aluminum struts are of different lengths due to the mounting angles. They also feature adjustable links. The long struts use screws, while the cross struts use a pin and keeper clip. I couldn't quite get the pin clip in until I squeezed the tips in slightly. Small metal pieces are used to assemble the strut cross members. I found the cross members a bit fiddly to assemble, But fortunately, once done, you don't have to take it apart again. Screw on the lower brackets, and then mount the wings. Now is a good time to make final adjustments to the strut length. Alright, it's starting to look like a real plane. Now is a good time to screw on the wing tips. I will be using a Spectrum AR637T 6-channel telemetry receiver, with the optional satellite receiver module to assure a good RF link. I will also be using a 2-cell 4000 mAh lithium polymer battery to power all electronics in the model. I like that this battery has several different connectors to choose from. Once wired up, she's ready for the radio setup. I should note that the door has a neat little clip on the wing to hold it open. Okay, so you will need to use a dual servo elevator setup on separate channels due to the control geometry of the two servos. On the DX8, it's pretty easy to assign an extra function to channel 6. Except I got one of the channels backwards. So just reverse that servo in the menu, and there we go. However, I thought I could just use a Y connector for the flaps, but no, they moved in reverse direction as well. Since I only have a 6-channel receiver, I'll need to use a reversing module on one of the flap servos. Now we're cooking with oil. Install the power and ignition switches, and we can move on to installing the fuel tank. There is a nice clamp included for the nipple. Plenty of room for the tank in the nose, where it is held in by a zip tie. I also hooked up the manual choke control, which will extend out the bottom of the cowl. Speaking of the cowl, I used some thin CA to harden the cowl screw holes. For the fuel filler line, I added a small hole for a retractable filling. It's pretty neat. A shaft collar makes a nice little handle for the choke control. The windows will need to be trimmed before using canopy glue to install into place. Some painter's tape is used to keep everything in place while it dries. The manual says to glue on the windshield and top window, but screwing it in allows easy removal for better access to the inside of the fuselage in case maintenance is needed. Same for the seats. Manual says glue, fit says Velcro. Since I'm using a telemetry receiver, I took a moment to set up the voltage displays and warnings on the transmitter in case the flight pack gets too low in flight. About 3.7 volts per cell is a good place to start to issue an alert. The peel and stick decals can be applied dry if you take the time to smooth out any bubbles. Or wet, which makes it easier to reposition things, especially for the large decal under the wing. I tried to trim the kit spinner to fit the prop, but it was just too small for the job. Instead, I use a true turn all-metal spinner, which you can get pre-drilled with a 4-bolt pattern. The machining is superb, and they are local to me. It fit like a glove and looked great. With just a final assembly check, we are ready for flight. propeller mount. That's it.